People reflect light, but there is also something invisible going on. We interact with our surroundings, sending out radiation that only special cameras can detect. Here's a view from above of warm people getting on and off an escalator in a cold station. After a fire, places that are still hot emit strongly and invisibly except to thermal cameras, as in this drone image. Whole planets, like giant Jupiter, do it. Visible light on the left and the invisible on the right. Even walls do it, but hot places do it more than cold. These folks are all sources of something that spreads out into their surroundings. There is a name for the process of spreading out from a source. It's called radiation. We use the same name for what spreads. In these images, it's infrared radiation that's moving out and out. When you emit infrared, you send out energy, so you need to replace it. The sun emits infrared radiation, a lot more than you do. It's much hotter than you. The sun doesn't run out of fuel so quickly. It's got enough for billions more years. We can't see infrared, but we can feel the heat. Emission of light and infrared both involve sending out energy. So our little planet experiences the warmth of the sun. It's millions of kilometers away, but it's still the source of energy for life on Earth. It's not just plants that can soak up the incoming energy. The sun's energy warms the whole planet. It stirs up the air. Some solar radiation, such as ultraviolet UV, is hazardous to health and life. The Earth's atmosphere provides some defense by absorbing most of the radiation before it reaches the ground. But if you are going to spend much time in the sun, then you need extra protection. These invisible radiations in sunlight, infrared and ultraviolet, travel to us through space, just as visible light does. They travel at the same speed. They are part of one continuous spectrum. They have wavelength that we can measure, but not the same wavelength as visible light. Infrared has longer wavelength. UV has shorter wavelength. It's possible, with the right equipment and from the right location, to photograph the sun using UV light. There's more to flowers than meets the human eye. Bees see things differently. A yellow dandelion is yellow enough to you and me, but not to a bee. Their eyes can sense UV light that the flowers reflect, and they see features that are invisible to us. There's more to the same spectrum. There are X-rays with short wavelength. The superhot layer outside the main sphere of the sun emits X-rays, shown as green and blue here. Fortunately, harmful X-rays don't survive the journey down through our atmosphere. They get absorbed and don't reach us here on the ground. There are also microwaves and radio waves with longer wavelength. They often allow wire-free communication. The whole range of radiations, including the little visible part with its colors roughly in the middle, is called the electromagnetic spectrum. The sun emits a whole spectrum of electromagnetic radiations, but most of them are invisible to us.